We are almost at the end of our course on calculus, and we've done quite a lot up to this point. So we've spoken about differentiation by first principles and then using our rules, and then we spoke about how to factorize cubic expressions and how to solve cubic equations. And then last time I saw you, I was showing you how to sketch a cubic function. So today I'd like to show you how to find the equation or determine the equation of a cubic function. This is something that often comes up. So it's something that we do have to be able to do. Okay, so let's have a look at, well, sorry, before we have a look at our first example over here, I just want to talk about something very briefly before we jump into all these examples. So I'm just going to scooch over to the side and then we can come back. There are basically three different scenarios or three different situations that you can have when you are determining a cubic equation. All right. So for example, let's just draw ourselves a set of axes like so. Those are not very good, but anyway, it doesn't matter. And let's draw a cubic function. So let's pretend that it's concave down and then concave up. All right. If we have a look, all right, in this form over here, the number over here compared to that number over there, compared to that number over there, those would be three distinct different roots. Okay. So that's one situation. Then in another situation, you could have something like this. So again, set of X and Y axes, and your graph could have a turning point on the X axis. So for example, let's pretend it does something like that. Okay, here we see two distinct roots. Okay, that's the second situation. Or we can have a situation like this, where rather unusual for them to ask us to find the equation of ones like these, but theoretically they could do. We could have a situation where the turning point is below the x-axis. So let's say your graph does something like that, and then you only have one root. Okay, so now linking this back to what you saw when you were in grade 11. Do you recall, and again, I'm just going to scooch over to the side a little bit here. Do you recall that you had to find the equation of a parabola when you were given the roots and one other point? Do you remember that? So for example, X and Y axes, and let's pretend and I'm literally just making up numbers here. So this is not necessarily going to work out beautifully, but let's pretend that's -6, that's 2, and let's pretend over here that this is -4. You could be asked to find an equation in this form, and you had to use a formula that's not on your formula sheet. It goes y equals a, x minus x1 or root 1, x minus x2. Do you remember that? Is this ringing a bell from grade 11? Yes, cool. Okay, so now the same idea gets applied to cubic functions. Okay, so if you recall in grade 11, this is what we did. We subbed in our roots, so we wrote y equals a, x plus 6, because it's minus 6, x minus 2. And then we used the other point that lay on the line. Often it's the y-intercept. It doesn't have to be. It can be any point that lies on the line. And then we subbed in our y and our x in order to work out what our a value was. So we put in the -4 over here, and x is 0 and y is -4. So here we've got 0 plus 6, and here we've got x minus 2, and then we would work out what the coefficient of a was. So in this particular case, it would end up being -12. This is -4, and as I said to you, a is not going to work out to be something very nice, but in this case, it works out to be 1/3, right? And then if you recall, you took that value, this 1/3, and you needed to go and sub it back in over here. And then you would have had to multiply everything out. in order to get the values of A, B, and C in your quadratic. So for example, you would have gone y equals 1 over 3, and then x plus 6 times x minus 2. Let's leave the 1 over 3 on the outside. This gives us x squared plus 4x minus 12. And then finally, we're able to multiply the 1 over 3 in. So that gives us 1 over 3 x squared plus 4 over 3 x minus 4. Okay, so what we've done in this situation, we found the equation of the parabola. Normally, it's in the form y equals ax squared plus bx plus c. So we could then deduce, well, a would be a third, b would be equal to 4 over 3, and c is equal to -4. That rings a bell. We're going to use the same concept in cubics. Okay, so when a cubic function has 3 distinct roots like this, we work with it as follows. We go y equals a x minus x1 times x minus x2 times x minus x3. Okay, so think about what we were doing last week. We factorized our cubic. A lot of the time we had 3 brackets, 3 different brackets, and we said these are the x-intercepts. Okay, so it makes sense now that we would be using 3 brackets multiplied by one another in order to get our cubic equation. And what we would need to do is we would then need to go and sub in these x-intercepts, use another point, work out the value of a, and that would give us our equation. Okay, is everybody happy with that? Does that make sense to everyone? Any questions? Nolutando, go for it.
Ma'am, does the equation y is equals to y minus y1 equals to m x minus x1 apply?
No, it doesn't, because that's for a straight line.
Okay.
That's for a straight line. Okay, so you can use that as an alternative to y equals mx plus c, but you can't use it for a quadratic or for a cubic.
Okay.
Okay. All right. So let's have a look at this example. It tells us g of x is ax cubed plus bx squared plus x plus d. Determine its equation if it passes through the following points. So if you have a look at the first 3 points, those are the x-intercepts, -2, -1, and 4. They've given us another point that lies on the function. They've told us 0 and -8. That is the y-intercept. Now, which letter, A, B, C, or D, is the y-intercept in a cubic function? Which letter? Can you guys remember? There we go, Lebogang. Well done. Okay, it's D. All right, so straight away, we know they're telling us that D is equal to -8. Right? However, this is what we need to do. We need to write down this equation as y equals a x minus x1, x minus x2, x minus x3. We can't use that 8 straight away. We're going to use it as a point that we're going to sub in. So we're going to use it as our y when x is equal to 0 because they've given us 3 roots. So our next step is to go ahead and go and sub those roots in. So we would end up with y equals a x plus 2, x plus 1, x minus 4. Now we're going to sub in the point 0 and -8. So y is equal to -8 when x is 0. those three brackets are multiplied together to give us the coefficient of A. So in other words, we've got 2 times 1 times -4. That gives us -8 times A equals -8. And when we divide by -8 on both sides, we would work out that A was equal to 1. Okay, and it makes sense because we know that A needs to be positive. The graph is concave down and then concave up. Right, so we were expecting a positive A value irrespective of what it might be. Now we've got to take that and go and sub it back into our second line of working. So in other words, this 1 over here, because it might not always be 1, we've got to take it and we've got to go and substitute it in over here. So we would end up with this. Therefore, y equals 1 times x plus 2 times x plus 1 times x minus 4. And now you have to multiply everything out. So what you would do is leave the first bracket as it is, it's x plus 2, and FOIL the second brackets. That's going to give us x squared minus 3x minus 4. And now in our last step, we have to multiply every term in the second bracket by x and every term in the second bracket by plus 2. So this would give us x cubed minus 3x squared minus 4x plus 2x squared minus 6x minus 8. So there you can see our minus 8 is starting to emerge. And now we can collect our like terms. So this gives us minus x squared and then minus 10x minus 8. Okay, and there is our equation of g of x. All right, any questions? Okay, where did I go too fast? Lebogang?
Oh, oh my gosh. Afternoon, ma'am.
Afternoon.
Ma'am, can I just ask why do we leave the first bracket like as it is?
Well, because you can't multiply all three brackets together at the same time. So you would choose two brackets and do FOIL and then multiply the other bracket by your quadratic.
Oh, ma'am, so we can choose any bracket to leave as it is.
Yeah,
That will not
absolutely. Absolutely. So if you wanted to do FOIL in the first two brackets and then multiply that quadratic by x minus 4, that's fine. It's not a problem.
Okay, thank you, ma'am.
Okay, pleasure. Okay. Palesa at the substituting at the last step. Okay, so Palesa, I was substituting in the x-intercepts. Okay, so where it was x minus x1, I substituted in -2 and I got +2. And then where I said x minus x2, I subbed in -1, and that's why I've got x plus 1. And then I subbed in my 4. Then after that, I subbed in my other point. Okay, the 0 and the -8. So this is my x, this is my y. So my y went here, and all my x's were equal to 0. Then I multiplied the three brackets together. 2 times 1 times -4 is -8. And then I divided both sides by -8. Right, once I've done that, I've got to go and sub my 1 back in. If I multiply 1 by anything, it's not going to change what I've got. So that's why I FOILed these brackets here, the ones in yellow, and then I multiplied my quadratic with x plus 2. Okay, and then that gave me my cubic equation. Does that make a little bit more sense? Are we good? Okay, Palesa. Nolatando, are we all good? Any other questions?
You guys are doing well, by the way. Well done. Nice, guys.
Okay. All right, so if there aren't any other questions, let's go ahead and go and have a look at one that you guys can try. Okay, it's identical. That's okay, Nadia, welcome. There's no picture this time, but that doesn't matter. Okay, let's just have a look. So it says f of x equals ax cubed plus bx squared plus cx plus d. It is a graph of a cubic function and it passes through the following points. So they've given us 6 and 0, 0 and negative 12, 1 and 0, and negative 2 and 0. All right, I'm going to highlight this one in a different color. Okay, determine the values of A, B, and C. So over here, if I wanted the values of A, B, and C, I would say that A was equal to 1. I would say that B was equal to negative 1. If I wanted C, I would say it was negative 10. And of course, D, we had already agreed on, that was equal to negative 8. All right, so you guys are going to try 1A in exactly the same way. Okay, give it a go. Remember, Yolanda and I are here
Yep,
if
we'll
you
be
need us
helping you
to
guys.
help you with anything. Okay.
Okay, going back a bit, I'm not sure. Maybe they, yeah.
There you go. I can't stay there, unfortunately, because we can't see the question.
Take a screenshot quickly.
Yeah, so screenshots quickly. And then I'm going to pop back down to the question again. Okay, and then when you're done, Matrix, you can just say done in the chat. You don't have to rush. Okay, cool beans. I'm just getting a jersey, Yolanda.
Let's go, guys. D is already done. Nice, D. Nice one. Uradile is done. Well done, Uradile. Nice, guys. There's still a couple of you that needs to be done. Apiwe is also done. Salma is
And
also
some-
done.
Okay, all right. So there are a couple of people that are finished. So just check your work carefully.
Yes,
And
please.
we're gonna go through the answers now.
Nice, guys.
There we go. Well done, everyone. Cool, Palesa. Okay. Nice, well done. Depends where Rowan or where to. Cool, so there's a few of us that are done by now. All right, anyone feeling brave and willing to share their answers? Good, Nonjapulo. Anyone feeling brave?
Come on, my people.
I
Do you
can't
want me to
swipe.
do this? There we go. Are you trying to help us, right? Emmanuel, are you going to help us with number 1? Nope, Emmanuel has disappeared.
Yeah, Manuel's run away.
Guguletsu, do you want to help us, please? You're done with yours. Do you want to share with yours? We'll be very, very grateful to see your answer. Guys, it's an honor to share your answer. You know immediately that once you are wrong, you get directed and you will understand. Because we are here to help you. So whatever you wrote, we'll take you through it with everybody helping. Thank you, Lusanda. Lusanda is up. Well done, Lusanda. You can unmute and talk to us.
Hi, ma'am.
Hi.
Ma'am, I'm gonna try, ne?
Yeah, go for it. Even if you get it wrong, it doesn't matter.
Yep, that's all that we want. Try.
Okay, ma'am. I first wrote the formula, which is y equals to a, and then x minus x1, x minus x2, x minus x3.
Beautiful.
And then I said y equals to a, x minus 6,
Good.
x plus 1,
X minus 1. You just made a little sign mistake there.
oh yeah, x minus 1,
That's fine. And then the last bracket was?
x plus 2.
Good. Well done.
Yes.
Good. And then what did
And
you
then
do after that?
I sub the point you highlighted in yellow.
Good.
And then y is equals to negative 12
Lovely.
equals to a, and then 0 minus 6,
Good.
0 minus 1,
Lovely.
and then 0 plus 2.
Good. That's great. Well done. Brilliant. Okay. Keep going. This is lovely.
And then I said negative 12 equals to 12a.
Okay. Okay. So lovely. That's perfect. Equals 12a. Well done. Okay. Because you got negative 6 times negative 1, which is positive 6. And positive 6
Yes.
times positive 2 is 12. Beautiful. So your value for a was?
Negative 1.
Oh, that's stunning. Well done. Perfect. Lovely, lovely, lovely. And now, what did you do with your -1?
I sub it again to the first formula, which is ax minus 6.
That's it. So you would have written y equals a is -1. And then here you've got x minus 6 times x
X
minus
plus
1, x plus 2. There we go. All right. Lovely. Well done. And then what did you do after that?
I left the first bracket. I just said negative x minus 6.
Okay, that's fine. So what you can do with this is you can leave the -1 and the x minus 6. That's what I always do. And then I FOIL the last two brackets together.
Which is going to be x squared
You're doing really
minus
well.
plus x
Good.
plus okay, 2.
So it's -2 at the end here because it's a negative times a positive. Well done. Okay, good. And then you can leave the -1 on the outside, and then you can
No.
multiply the x minus 6 with x squared plus x minus 2.
And then it's going to be x cubed
Good.
plus x squared
Good. Well done.
minus 2x
Excellent.
minus 6x squared
Good.
minus 6x
Perfect. Come on, pen. Yes.
plus 12.
Plus 12. Oh, that's awesome. Well done. And then I think what I would do is just leave the negative on the outside, collect your like terms together, and then we can remove the brackets and change our signs.
Yes, and then it's going to be minus 7x.
To write your x squared term first, so it would be x squared minus 6x squared, which would give you minus 5x squared. And then, do you want to keep going?
Minus 8.
Good, minus 8x, lovely, good, well done.
Plus 12.
Beautiful. Oh, you've done a fantastic job. Well done. So all we need to do now is remove those last brackets. So this would give us a final answer of?
I think, ma'am, you're going to have to divide because you have to remove the negatives.
No,
Fine.
so you would do that when you are factorizing and you've made it equal to 0 and you want to solve. Remember, you are doing the opposite now. You are finding the equation. Okay, so you're going to leave it as y equals because that's how they want it. And you're going to multiply each term by -1. Does that make
Okay.
sense?
Yes, ma'am.
Okay,
Then it's going to be negative x cubed
good,
plus 5x squared
good,
with x
good,
minus 12.
beautiful. Oh, that was stunning. Well done. Well done. That's absolutely perfect. Okay, wonderful, wonderful, wonderful
Thank
work.
you, Lusanda.
Okay. Well done, Lusanda. Okay, so Lusanda says A is -1, B is 5, C is 8, and D is -12. And she's certainly 100% correct with that, Lusanda. There you go. So all you've got to do is just have the courage to try. Even if you've got one mistake here or there, it's not the end of the world. We're not here to judge you. We're here to help you. Okay, brilliant. Anybody get something slightly different and wants to ask a question before we move on?
And take screenshots.
Yes, take screenshots. Okay, so there's a couple of hands up. Okay, Lebogang? No?
Oh no, yes, ma'am. Ma'am, I wanted to
Oh,
ask. I did get everything right, but for the when you sub in the y-intercept, ma'am, do you always sub in the x value of the y-intercept? Because I was
yes.
worrying that. Okay.
Yes, you do. So let's say they gave you a different point. So let's pretend, let's just go back up to this picture over here, and let's pretend they didn't give us that point. And I mean, I'm not saying that this point does lie on the line. I'm just making up information here, all right? But let's say there's a point over here, and let's pretend its coordinates are 5 and 3. Then this would be your x and that would be your y. So when it came to subbing in over here, okay, over there, you would make that the 3, and then instead of 0 over here, you would end up with 5.
Okay, thank you, ma'am. Because I was trying to
Okay.
all the y-intercepts was 0, ma'am.
No, no. So the x coordinate of your y-intercept will always be 0. Often they give you the y-intercept just to make life a little bit easier. It just means it's simpler for you when you have to multiply these 3 brackets together to get the coefficient of a. But theoretically, they could actually give you any point that lay on the line, any other point that lay on the line, and it would work. Okay. All right, wonderful. Good stuff. Well done, everybody. Okay, let's go and have a look at something that is a little bit different. Now, what I am showing you here is what I was talking about at the beginning of the lesson. Remember, I scooched over to the side and I showed you this pink one over here, where you had your turning point, one turning point on the x-axis, okay, and another point, right? I don't know if you remember this from last time. It's not difficult, but in the beginning, it's you don't know that unless somebody points it out to you. When you have a graph that has a turning point that is also an x-intercept, something very interesting happens. So if we go back to what we were talking about with our y equals a times x minus x1, x minus x2, we find that when a point is a turning point and an x-intercept, then that bracket will always be squared. So in other words, what ends up happening is this. Okay, so in this particular example over here, we would say y equals a, x minus x1, so that would be x plus 3. And then here we would say x minus 2, and that bracket would need to be squared. Okay, so when a point is an x-intercept and a turning point, the bracket is squared. And this always happens. Okay, so very important. So when a point is an x-intercept and a turning point, the bracket will always be squared. Yes, Teddy. You're welcome to unmute and speak, Teddy.
Hey, ma'am. I just wanted to know, is there a reason why, or is it one of those whereby you just have to know it?
There is a reason for it, but you don't need to know the reason why. You just need to know that it always happens.
Okay. Thank you, ma'am.
Okay, all right. Okay, so yes, it's just something that always happens when you've got a turning point that is also an x-intercept. Okay, the other thing that they have told you in this particular case is if you have a look in front of the x cubed, they have told you that the number in front of the x cubed is actually 1. So what I should do here is I shouldn't use a in this case. Let me rather use another letter like a Q. right? Because they've got a over here and it wouldn't be the same a, all right? So in this case, they have told us that the number in front of the x cubed, they have told us it's -1. So what they're implying here is that q is equal to -1. So over here, I can actually sub in my -1. I don't have to work that out first, right? Because this has been given to me. But what I would need to do now is multiply out my brackets. Okay, so in the same way in the question above that Lusanda did for us, we will leave the -1 and the x plus 3 on the outside. Then we need to square our binomial. This leaves us with x squared minus 4x plus 4 when we've squared our binomial. And again, we can leave that -1 on the outside. We can remove our round brackets. This would leave us with x squared minus 4x squared plus 4x plus 3x squared minus 12x plus 12. And again, I'm going to leave the -1 on the outside. Collect, oh, sorry, that should be a cubed. X cubed minus x squared minus 8x. Have I made a mistake, Matrix? Yolanda, have I made a mistake anywhere?
Not so far, no. I don't see any
Okay.
mistake unless if I can't point it out. But at this moment, I think we are still okay.
Okay, all right. I just saw some hands go up, so I didn't know if I'd made a mistake. Teddy, I don't know if your hand is still up from earlier.
Sorry,
Yeah,
ma'am.
hands have gone up.
Nolutando, do you have a hand up? You want to ask something?
Ma'am, where does the x minus 2 squared come from?
Just sorry, I'm just replying to Nhlanhla in the chat. Just give me 1 second. Sorry, I'm just replying to Nhlanhla. Just ask your question again, please.
Where does the x minus 2 squared come from?
X. Oh, okay. So that was the part that was the point that I was trying to make in the beginning. Okay. So the x minus 2 comes from this point over here where I'm putting the pink arrow, because that point is an x-intercept and it is a turning point. So if you have got a point on the graph that is an x-intercept and a turning point, then the bracket that that value goes into must be squared.
Okay.
Okay. All right. Now, the reason that this happens, okay, so Teddy, you were asking about this earlier, but you know the reason why, but nobody's ever going to ask you to explain it, but you actually do know the reason why. Think about a graph like this one, a parabola that has its turning point on the x-axis. We would call it a perfect square trinomial. So if I say this is the graph of f of x equals x squared minus 6x plus 9. If you wanted to factorize and solve for the x-intercept, you'd let y be equal to 0, wouldn't you? And then you'd end up with, sorry, let me just do it the long way. So you'd make y equal to 0, and then you'd have your factors. And because this is a perfect square trinomial, both of your brackets would be identical, wouldn't they? So now another way of us writing that is like this. It's the same thing. There's only one solution, okay, because the roots are equal. So in this case, x would just be equal to 3. It's the same idea. Okay, Teddy. So because you've got a turning point that's also an x-intercept, your bracket is squared. Okay, does that make sense to everybody? Are there any other questions? Please do take screenshots. Hi, Ayanda. All right, now, in Nhlanhla, does that make sense to you? Okay, so you can only square the one, okay, that is the turning point and the x-intercept. Okay, you can't just square any one. It's not going to give you the same thing. Okay, I hope that makes sense now. All right, how are we feeling? Matrix, is this okay? Thumbs up, thumbs down? You okay? You sure? Okay. All right, so we're getting a whole lot of thumbs back. Thumbs ups. Can you go back a little? Sure. If you were, where do you want me to go back to? Okay, so now I can see Ayanda and Leanna asking questions. Okay, I'm just going to read your questions quickly. Okay, so Ayanda, we're going to do ones like that now. Okay, where you have to solve simultaneously. Okay, so if they don't give you D, right, so in what you've written over here, you are implying, so by what you phrased, Ayanda, you're implying that D is equal to 0. So in other words, the graph would go through the origin. Okay, but I'm going to do one where we do it simultaneously. Okay, so Leanne, if they give you, so that's like the last situation. Okay, what do you think you would use, Leanne, based on the conversations we've had?
Ma'am, with that question, I actually get stuck because there was a point where we had like a graph. You could see that there were like 3 x-intercepts, but they didn't even give us one. And then they gave us a y-intercept and a turning point.
Okay.
So, ma'am,
Okay, so then in that situation, so then you've been given a question like one of the ones that I wanted to do this evening with you, all right? So what you'd have to do is you'd have to solve simultaneously. All right, so there would have to be some information that was given. So like the one that's on the board now, maybe they tell you what the coefficient of x cubed is and they give you the D value and then they ask you for the A and the B. Something like question D. If you have a look at question D that's on the screen at the moment, something like that.
yes, something like that. Yes.
Something similar to that. Okay. All right. So we're going to go and we're going to have a look. We're going to have a look. Okay. So just give me 1 second. Sisipo, yes, that's correct. Okay. On the purple graph. I'm not sure which purple graph. I think it's EV. Is it EV where? Everywhere. Just give me 1 second. I'm going to try and go back to that. What about something like this, Leanne? Question B. So f of x equals ax cubed plus bx squared has a local turning point at 2 and minus 4. Find the values of a and b. Is that the sort of question you're talking about?
Yes.
Okay.
It's
All right.
that one.
So it's that one. Okay, so let's have a look at this because this is something that I wanted to do with you. All right. So we're looking at question B, everybody. We're looking at question B. Okay. So this is what you've got to do. You've got to sub in the point that they give you. All right. So remember, this is your X. This is your Y. So if you have got f of x or y equals ax cubed plus bx squared, they are implying that the values of c and d are equal to 0. Okay, and we're not calculating them. So the first thing that you would do is you would sub in the point that they give you. In this case, 2 and -4. So you're going to say -4 equals a times 2 cubed plus b times 2 squared. And you're going to get an equation in terms of a and b. So this will be 8a plus 4b. And you can actually leave your equation just like that. The other thing that's important here, Leanne and everybody else, is that they are telling you it is a local turning point. So you know that at the turning point, the gradient is 0. Okay, so at the turning point, you know that your gradient, which is f prime x, is equal to 0. So what that means is that you need to work with the derivative. So you will say f prime x equals, and here we would end up with 3ax squared plus 2bx, like so. Does that make sense to you? So the gradient at the turning point is 0. So now you're going to sub 0 for the gradient. And you know what the x coordinate is at the turning point. So you know that it's 2. So you are going to sub in 2 in place of x. And you have another equation in terms of a and b. So that would be 4 times 3, that would be 12a plus 4b, and that would be your second equation. That's what you do. Okay, Leanne? Amahle, I see you've got a hand up.
Yes, I do. Good evening, ma'am.
Good evening, Amahle.
Could you please explain question B again? You lose me when we start the f prime.
Okay, all right. So in other words, the problem, Amahle, with this particular question is the fact that they have only given you 1 point. Okay, they haven't given you a whole lot of points like they've done in this previous questions over here. They've only given you 1. But they've been very clever about what they've given you, because this point is not just a point that lies on the graph, it is also a turning point. That's critical to being able to answer the question. So irrespective of what this graph looks like, okay, you know, I mean, if the graph looks like that, you know that the gradient at the turning point is 0. The gradient at the turning point over here is 0.
Yes.
Right. So that's the key to being able to solve this problem. Subbing in the 2 and the -4, that's sort of fairly easy. Okay. But here, because they told you it's the turning point, you took the derivative. Remember, the derivative, the first derivative is the gradient.
Oh, okay.
Okay, so what you are saying is that at the turning point, the gradient is 0. Yes.
Okay, thank you.
But you can't have an A and an X and a B that's unknown. So you know what the X coordinate at the turning point is. You know
Yes.
that it's 2, and that's why I've subbed this 2 over here. Does that make more sense now?
Yes, that does. Thank you so much.
Okay, pleasure, no problem. Okay, so Leanne, they will have to give you a little bit more information than that. Okay, so they could give you C and D. So if you have a look at question D over here, all right, they have told us that B is -3 and C is -12. They want us to work out what M and N are. Okay, so they can't give you 4 unknowns. They can give you a maximum of 3 unknowns, but then there's a sort of a little bit of an algebraic manipulation that has to take place. But most of the time, it's going to be 2 unknowns that you would need to solve for simultaneously. Okay, right, so they can't make it impossible for you. There's got to be something that you can do somewhere with the information that you've been given. And now matrix you would solve simultaneously. So you've got minus 4 equals 8a plus 4b. Maybe the easiest thing to do would actually be to work with this equation over here and say negative 12a equals 4b, and then divide by 4, so b would be equal to negative 3a. And then that's equation number 3. And then we can go and sub back into our other equation, the first one. So minus 4 equals 8a plus 4, and then b was equal to negative 3a. And then we'll be able to solve for a. So we get negative 4 equals 8a minus 12a. That gives us negative 4a is equal to negative 4. So a would be equal to 1. Using this equation over here, number 3, we would solve for b. And we would say that b is equal to negative 3 times a. So b would be equal to negative 3. Okay. All right, Lebogang, I see you got a hand in the air.
Oh, ma'am, would we be penalized if we just use elimination?
No, not at all. Not at all. I personally prefer elimination. But I didn't know how you guys felt about this, but this is a great candidate for elimination. Let's just have a look. You've got negative 4 equals 8a plus 4b. You've got 4b over there, so you go 0 equals 12a plus 4b. So we want to eliminate our b terms. So because the signs in front of our b terms are the same, we're going to eliminate by subtracting. So we're going to say minus 4 minus 0 gives us negative 4, and 8a minus 12a gives us negative 4a. Can you see we end up with the same answer? So no problem at all. I love elimination, especially in these sorts of questions. Okay, no problem at all. Teddy, I see you had a hand up.
Ma'am,
Hello.
I just wanted to know, when should we know that we have to use the derivative? If they tell us it's local turning point, then we know somewhere we have to use the derivative.
Absolutely, because they have told you that it's a turning point, that's how you know that you've got to use the derivative. Okay, because the gradient at the turning point is 0. All right, if they didn't tell us that 2 and minus 4 was a turning point, we wouldn't have enough information to be able to answer this question. It's only because it's also a turning point that we're able to do this. Okay.
Sorry, I'm just gonna launch my poll if you don't mind. Like this,
No,
you can do
that's
the poll
fine.
before my time ends. Thank
All
you.
right. And Nolutando, was that from earlier? Was your hand up again, Nolutando?
Let's participate. It's on the poll. Nolu, you still have some minutes to ask your question if you want to ask another question. Okay. I see Lebohang has joined on the question list.
Lebohang, you can go for it.
Wait, no, sorry, ma'am, can I also ask, there was another thing we were told at school about how, if I can remember correctly, how the cubic function can also be calculated into, like, is it the quadratic function?
Yes. So that's called the derivative of the function. Now, unfortunately, I'm not going to have enough time to be able to cover that as well, because obviously our classes, I mean, we only get together twice a week for 1 hour. But yes, when you are taking the derivative of a cubic function, you get a parabola. And when you take the derivative of a parabola, you end up with a straight line. So that's becoming sort of quite more difficult work. But yes, that is something else that has to be considered as well. Let me just see, what was I? I'll have to, I may be able to do that with you next week. Sorry, not next week, on Thursday, but then it means that I'm not going to be able to do any of the exam type questions that I wanted to do with you. Okay, but yes, you could see that as well. Okay. But you have to do finding the equation before you can do that in any event. All right, so guys, why don't you try C for homework? Okay, it's very similar to question B. It's only slightly more difficult. And again, you'll have to solve for A and B simultaneously. Okay.
No, Lutando, your
Ma-
hand is up again. There we go. You can ask.
sorry. Would it still be okay if I use the first derivative and the second derivative?
You can use the first derivative for what we're doing at the moment, but the second derivative is not going to help you. Okay, because your second derivative is your point of inflection. All right, so we're not using the point of inflection when we are determining the equation of a cubic function. The first derivative can help, but the second derivative can't. Okay.